Okay, so far we've been looking at blocks lying on horizontal surfaces. That's all going to change with this lesson here. So example 5, we've got a box of mass 10 kilograms that's on a smooth slope angled at a horizontal 15 degrees. So the first thing we're going to do is try and draw a diagram of this situation. So the slope here would be the horizontal, but we are going up an angle of 15 degrees here. And what we've got is we've got the block of 10 kilograms on the slope like that. And obviously, as we can imagine, what's going to happen with that block is it's going to slide down the slope, okay? And that's going to happen basically because there's a force of 10G pulling it vertically downwards, right? Because it's a slope, that will also pull it down the slope. The only other force that's going to be acting in this situation is the reaction force. Much like when the block is sat on a table, there has to be a perpendicular force to the surface that stops the block from falling through. So there'll be a reaction force there. And that's the first thing that part B asks us to find. Now, what we're going to do is we're going to combine the work we've done on force equals mass times acceleration with the work that we did last lesson for resolving forces into different directions. So the first thing I'm going to look at is to find the reaction. We're going to resolve, and instead of resolving horizontally and vertically now, we're going to resolve perpendicular to the slope, and we're going to resolve parallel to the slope. So the first one is perpendicular to the slope. Now obviously in the perpendicular to the slope direction, it's not sinking through the slope and it's not taking off, so they will be balanced in equilibrium. So this is R acting in that direction. That's going to balance with this force here. But look, this force here is not acting perpendicular to the slope. This is perpendicular to the slope that I've highlighted here. And this force, the 10G, is acting vertically downwards. So we're going to have to do what we did last year's lesson, which is to adjust. And the way we do that is we firstly imagine that we've got a little right angle triangle. It's always going to be the same. It'll create a right angle triangle here. And that tells us that this angle, if this is 90 and this is 15, this will be 90 minus 15, which is going to be 75. So then when we look at this, we can see that to get from the 10G to this dotted line, which is the perpendicular direction that we're resolving in, we're going to go away from the angle of 75. And as we saw last lesson, that's going to give us 10G, the size of the force, but then it's going to be sine 75 because we've moved away. And we can pop that into our calculator, and that will tell us the normal reaction force on the table. So this is 94.7 to 3 significant figures. That's part B. For part C, it asks us to find the acceleration of the block. So firstly, we know the block is going to be moving down the hill. So what we're going to do is we're going to resolve in a direction down the hill. Right, so not horizontal and vertical resolving, never when we've got an angled plane are we going to do it. We're always going to do it with the slope and perpendicular to the slope. And the only force affecting it, the only force in our diagram here, is the pulling down the slope by the weight. So again, it's not directly down the slope, it's this 10G to get down the slope. We've got to go through the 75, so it'll be 10G times cos 75 because we've gone through the angle to get to this downward slope. Then we do force equals mass times acceleration, and we get 10G cos 75 equals 10A. Then we divide by 10 and we get that A is G times cos 75, which gives us 2.54 meters per second squared to 3 significant figures. And they are your 2 answers for that question.